Hi, Rob. Thank you so much for introducing me. And I'm so excited that during this conference, after almost 2 years, we are finally introducing NitroPack. In these slides, I'm trying to explain more about the efforts that we made, the reasons that we made NitroPack, the technologies behind it, and what we can expect for the next steps. So directly going to the introduction, so firstly, what is Nitro project? Nitro is actually a new abstraction layer that we designed especially for Nuxt 3 that using this, it enabled us to write in a server that we could use different bundlers like Webpack, Vue, or different technologies using targeting different runtimes like Cloudflare workers, like Vercel, Lambdas, and etc. And with all of this, we wanted to make it as much as easy as possible for the end users. So changing the framework, changing the runtime, changing the code should be no hassle. It should be just one configuration and all is done. Well, at the beginning, it was seeming impossible, but nothing is impossible. Nitro project was started back in November 2020. I remember it was Friday. We had an evening bi-weekly meeting with the Nuxt community. And we was talking about integrating with Cloudflare workers. Back in the time, Nuxt 2 wasn't ready for this because it was depending on Node.js and setup that wasn't designed to support a new environment like workers. So it started as a quick idea to see how we could modify Nuxt 2, hack it, and make something that can actually work for Cloudflare workers. And by surprise, it wasn't so hard. It just took a few hours, and it was almost the birth of this project. But so far after that, we started to innovate based on this idea. Almost we had 600 commits until now on this project that enabled us to target more servers, add more advanced features like Typescript support, like API routes that we'll see in the next slides, and some packages that are added to the stack slowly. Today, Nitro provides more than 10 environments to be deployed on, which all of them are available for Nuxt 3 users. And it's also powering the Nuxt 3 server-side rendering using a custom solution that you will see later on for Vue.js and version 2 and 3, which actually makes it possible for using it for Nuxt project even today. One of the most important things that we made us to think about creating something like Nitro was the runtime features. Right now, today, most of the server applications, if you want to develop a server, an API, that you want to write it using JavaScript or TypeScript, the normal assumption is that, okay, this is a Node.js server, and it's also applying for the server-side rendering and even front-end frameworks when they want to do server-side rendering. And unfortunately, many of the NPM packages, while they're awesome, they are depending on Node.js. And while Node.js is also nice, with the new possibilities that are provided to us, there are new opportunities. And these opportunities require to use JavaScript, modern JavaScript, but not depending on the Node.js only features like path module, like process.env, things like this that are normal for server development, but are not available in an environment. And there are other new runtimes like Cloudflare workers. They have their own storage system. There is Dino.js project that is going to renovate and rethink about how Node.js started to adapt with the modern JavaScript platform. And native applications, which are amazing, like Vue native or React native, but they are not Node.js environment. They use JavaScript for their rendering, but they are not Node.js exactly. And most importantly, the browsers themselves, which are nowadays much more powerful than they was 10 years ago. Browsers can now run assembly code. They can even do server-side rendering. You could even run an environment and packages that was already designed for Node.js right inside them, which are exciting possibilities only if we could use them, only if we could move away from depending on Node.js for server-side rendering. And based on the target that we are deploying to, there are some vendor-specific features. Some platforms support their own caching system, their own database integration, their own system for optimizing images, which are amazing, but they differ how to be implemented. And the goal of Nitro project at the beginning was to make it abstracted, make it possible to write one-time code that is not targeted for any environment or vendor, but it works with any vendor. So that's the challenge. And like anything else in the Nuxt.js ecosystem, we wanted to have a zero config experience. Targeting modern environments requires more knowledge, requires more complex setups, but at the same time, developers should be able to adopt these new technologies without spending their time to actually learn about them. The only thing that they should we believe that the only thing that they should focus on is the code, is their idea and what they want to do, not for the complexities of setup and maintenance of the dependencies. And how it's making possible using an abstraction layer. Using an abstraction layer on top of the setups, both Nuxt and Nitro are able to make it easier for the users to read and write the code, but it's also making versatile to changes. So if we want to introduce a new modern web platform feature, if we want to introduce a new integration, it's hassle-free for the end developers. They have to just add the configuration probably, like a Nuxt module. The other hard part is choosing the right provider. Nowadays, there are many great providers that you could choose to finally deploy your project, but choosing one of them is sometimes a hard decision because each of them has their own unique features, their own unique pricing. They provide different scalability and hosting system. But when you are going to start a new project, it's tricky because you can't predict that what we are going to use in the future. We can't predict that what would be changed for the project goals and what if they change, which comes to the next point, migration. Migration from one of these solutions to other one costs a lot. You have to learn their SDK. You have to read a new set of documentation. You probably need to write your code base again to integrate with their unique features and how you bundle for it, how you deploy to it, which we don't want it with Nitro. We want to make it as easy as possible, just focusing on the code and not worrying about anything like the provider, while being able and rest assured that we can choose the best one that is fitting for us, or even probably choosing some more than one of them based on the same code base. And the third thing is, which is more concerning the frameworks right now, is the different names for the technologies. And these technologies are not often standardized. Like the way that caching is integrated in different providers, because of the marketing reasons and some other things, are usually not the same, while technically they are the same, which is confusing for the end users and by end users, I mean developers. We need a caching. It doesn't matter what technology is called by a vendor. And this is also confusing sometimes if you want to choose the right one and we can't compare them equally, which is another thing that Nitro project is trying to solve it. And the last thing is the development experience and deployment experience. Each of the platforms have their own unique deployment system and usually their own tooling to create a server for them, while they are different. So the experience between them is different. While Nitro's goal is to provide a consistent experience between them. The third thing about Nitro and the third goal is being framework agnostic. Usually when you want to create a new setup, you have to make another research, choose another framework that is fitting for you. For example, you choose Cloudflare and Vue.js. Then you find for the solutions for it. But we want to make it easier. We want to make it easier to choose any part and easily replace it in the setup. And the current solutions, even the open source ones, are usually targeting a combination of them, while it's not configurable to choose something else. And this is usually making hassles because it takes time to replace one part of it. And the other thing is the technologies are moving forward to make backend and frontend closer together. Instead of developing a backend like an API with a different technology, we could now use the same power of the same JavaScript framework to develop a full stack experience, which agnostic development system makes it possible. So because of this goals, we made something called Nitro, which the goal was that creating a small core that is versatile enough, is abstracted enough, providing different providers, frameworks, and targets, and adding more features, good development experience, and add it for the Nuxt.js framework. To make it possible, we use some existing functionalities and the package that was already in the ecosystem. Probably the core part of the Nitro is rollup and ES system. Using rollup, Nitro is able to bundle the code that you write in Typescript or JavaScript. It can do the transformations using plugins and builders like ESBits so quickly, and it can even convert the legacy code, the packages that are written in older code like CommonJS or even targeted for browsers, to a moderner ESM syntax that can be finally deployed everywhere. And in the next steps, we are working on replacing rollup with Vue for development, which they have the similar API, but it's much faster. And thanks to Anton's project and Vue.js and created the Vue Node project, it's almost possible nowadays. The other part in the Nitro stack is storage layer. Depending on the deployment system, it's usually tricky to choose the storage. But if you are writing a legacy server, it's easy. We just depend on the file system, whether it's on the server or it's on a laptop or development environment, and we just save files on it. But it can be tricky if you want to deploy it on a worker environment, for example, if you want to deploy it on an embedded device, if you want to deploy it on a serverless deployment that has not one node, but more than one node, and you need a shared file system layer that can work between nodes. So we came up with our own in-house solution called Unstorage. And Unstorage goal is super simple, like a Unix philosophy. It starts with a single storage layer, which we can create. And similar to a Linux system, we can mount different storage on different paths. So it doesn't matter how we are going to write to a file. We just mount the output. It can be a file system. It can be Redis driver. It could be a database. It could be just in a memory. And by usage, we just write to a path. It doesn't matter how it's handling. Nitro is handling it by default, and the storage layer is provided out of the box. So the Nitro itself, all we have to do is to write this set item. But it's also possible to indirectly use this unstorage package. You could create your own solutions and read more about it in the Node.js unstorage repository. This is making it possible to create a Node.js npm package that is abstracted from Node.js and following this philosophy. The other part in the Nitro stack is HTTP framework. We was doing a lot of research about finding a right HTTP framework to use it for Nitro. And most of the solutions, unfortunately, are assuming a runtime. They are usually written for Node.js in mind, or some new ones for Dino, or even some new ones for workers. But none of them was abstracted. They was depending on a platform. There wasn't pure JavaScript HTTP frameworks. And because of this, we ended up with the HTTP project. H3, which is short for HTTP, is a super simple stack runner and router that we can use it to create a web server similar to Express applications, and at the same time leveraging from the modern features like async await syntax, or even using it for backward compatibility to use your already have Express middleware inside it. So it's backward compatible, it's modern, and it's not depending on any runtime environment. And in the blue example, you can see how it's easy to possible to bind it to a Node.js application. While if it's not a Node.js application, we can bind it to different bindings like workers. The other part, which I would say probably is one of the most important parts of the Nitro stack, is Unmarked project. In an ideal world, no npm package should depend on Node.js or browser runtime. But in reality, probably a high percentage of npm packages that we use daily and are available, and it's kind of the full power of the npm ecosystem, they are depending on Node.js. So we didn't want to miss that. We didn't want to tell users, okay, you can't use anything from npm unless it's agnostic, and you have a limited set of choices. Instead of that, we have to drop Nitro magically just transfers these legacy packages into an independent friendly package. So the code is transferred with any dependency that it has with Node.js with the equal version that is marked. And this marked version sometimes depends on runtime of Nitro for things like storage, for even some Node.js internals. We rewrite them in a pure JavaScript form, which makes it possible to just use any npm package that was designed initially for Node.js, but without depending on Node.js. And we didn't stop here. We moved a little bit more further. And for some popular packages like etag or mime, we created an equal version that is more modern, and it's more minimal. And it just replaces the original package with less bundle overhead. So when we are deploying to limited environments like workers, we don't have to worry about the bundle size anymore because they are minified magically. And if anything is not available and is not already marked, Unmarked provides an auto-marking framework. So it appears to the consumers and npm package that they are using Node.js, but in fact they are marked. And this powerful marking framework makes it possible to have almost any npm package, including Express, in any environment like Cloud Web Workers. You can read more about the source code in on.js on-env. It's also possible to use on-env for your own configuration preset if you have your own rollup configuration. Or you can use it already with the Nuxt 3 or Nitro. One of the other parts in the Nitro, which is actually adding something new to the top stack and for the experience, is our Nitro routes. To create an API route with Nitro, all you have to do is to create a Typescript file inside API directory. And this file should simply return an object or even a string. This string would be automatically converted to a JSON response and sent back to the user. And it's not even limited to that. Nitro API routes have two very, very special integrations with Nitro if you are using it. First of all, they support direct SSR calls. What is direct server-side rendering call? When we are rendering a web page on the server part, we usually need to make some API calls to fetch user data, to fetch some blog posts, etc. And in traditional web applications, each of these requests requires to create another sub request on the server side to the backend side and backing forward. This is usually the bottleneck of the performance for the SSR applications. With Nitro API routes, we just removed all of this latency. There is no HTTP call anymore. Even if you fetch something on the server side, it's directly calling the function. And with this powerful API and the mocking that Unmarked provides for us, these functions can be just like normal Node.js request handlers. So we don't need to create a special function. They are normal functions, but Nitro provides a way to remove all of this latency and make it possible to run the SSR calls right inside the same lifecycle hook. And one other interesting feature about Nitro API routes, thanks to Daniel Rowe, is Typescript integration. When you are developing as API routes and adding API hello.ts, if you fetch it somewhere else, you have Typescript auto-completion, not only for the route, but also for the types of returning type and whatever it accepts. So you don't need to even think anymore about what APIs you had available. You could just depend on your IDE or the completion, add your API file, and you can use it right out of the box. And in addition, this also provides a robust type checking system, which also gives you more confidence when you are writing an API route and consuming it on the same application. One of the unique features of Nitro is that it removes any dependency on node modules. Usually when you want to deploy your server application to a hosting platform or your own VPS, we need to install all of the node modules that was required for the runtime. But this is usually a problem because node modules is huge. It's like a black hole. And for deployments like Lambda and environments that are limited in terms of storage, sometimes we could just overuse it. Nitro, thanks to the NotePack, thanks to the rollup, can bundle every source code that we have. But what about externals and the dependencies that we use? Well, we could usually think we can bundle also all of the dependencies, but it also comes with some drawbacks, and some dependencies are not designed to be bundled. So instead of that, thanks to very unique features that Versal guys create, a project called NFT, Nitro is able to extract these node modules and just pick up the files that was required for our server and then move them back to the output directory. This output directory is all standalone. You could deploy it as a serverless function to any environment you want without need to installing a dependency or depending on any runtime feature. And this output is super minimal because of the optimizations that we do on the rollup side. It can be minified, it could be true shaken, and it could be in a modern format with chunks, dynamic chunks. And these chunks are a unique feature again, because with a normal Lambda application, we have to always worry about the bootstrap size. If we have more dependencies, if we have more pages, we have more API routes, the startup time will increase. One common solution that we was using in the previously was to split it into different lambdas, but it's making it hard for us to deploy an application, a server application, because then we have to over-engineer it again. We have to split it different API routes that each of them has less cold start time. With Nitro Bundle and Output Bundle, we use a technology called lazy chunk loading. Same that happens on the browser side when you don't need some code, it's not loaded, and it's loaded only when it's needed. The same process happens for a server side. The different parts of the code that you write in the server, they are not loaded immediately when we start a server or invoke a Lambda function. They are only loaded when we need them. And this is making it amazingly fast with a super fast performance. Like for Nuxt.js, it was in order of 100 times for the startup time. And also making it super small. If you can see, a basic application costs like 85 GCP size for a worker environment. And this is making it easier. So we could add more code without worrying to reaching any limitation. And we could deploy faster because there is no huge node modules overhead. And this one is also independent. So we don't need to install any dependencies or worry about versioning. Nitro finally has also an SSR integration. Server-side rendering is a technology to run and render a page that is rendered in a browser, but in the server side. Usually this setup is quite complex, and it's usually the job of the frameworks like Next.js or Nuxt.js that provide a setup for server-side rendering. With Nuxt 3, we ported a special feature of Vue 2 called Vue Bundle Renderer for Vue 3 support and integrated with Nitro. And this made us possible to not only use Nitro for the API handling and server handling, we could also use it for server-side rendering and a universal rendering experience. But Nitro could be also extended. So in the future, we could think about not only supporting Vue.js SSR rendering, but also React.js or even native rendering for native mobile applications. This is all thanks to the abstraction that Nitro provides us for rendering and adding on-demand renderers. One proposal that we are working on is about route caching. Usually it's we had two choices in the past. We could either run a full server in production that each request could be served immediately for users. So each user that was viewing a blog page, it has to make a call to the database, fetch the blog data, and show it to the user. Or alternatively, using Nuxt Generate to pre-generate all of the pages and cache them on the CDN. But the second jump style has its own downsides. We couldn't make it live edits. If we want to change one page of the blog, we had to redeploy the whole website. In Nuxt 3, we was thinking about what it could be possible if we could merge these two things together. So some pages could be peer-generated, the pages that are less frequently changed, and some routes could be rendered on demand. Or even for some routes, you might want to have your own custom caching strategy, like stale revalidating, or you might want to disable server-side rendering. Based on different target deployments, different providers, this configuration is usually different. And without an abstraction, it was almost impossible for users to do this unless you have to make your own complex setup. With new route caching system, we could develop one web application using Nuxt.js or Nitro and define different strategies for different routes. And Nitro, out of the box, generates the files, the configurations, and generates the routes that was specified and apply the caching strategies on demand in the runtime for the rest of them. So instead of depending on the vendor-specific features, we could just rely on a super simple configuration and expect Nitro to do the hard part and take care about caching strategies. This is going to make a revolution for hybrid rendering possibilities. We could merge the possibilities we had with Nuxt Generate and Nuxt Start together with even more caching possibilities. NitroPack was initially, as mentioned, an experiment for Nuxt.js project in almost a year ago. Over the time, we iterated over it. We converted to the module. We then moved it to the Nuxt.js or Nuxt 3 project to make it faster to iterate over and improve Nitro. But at the end, it was fully making sense to make this feature available for everyone to create your own solutions, test it independently, and add more features to the top of it without the complexity of the setup. So we started a proposal on November to move this NitroPack to an external package. And this refactor is almost ready after a few iterations, and we hope to make it public as soon as possible. And waiting so much for your feedbacks. And thank you so much for your attention. I hope it wasn't a complex presentation. It was mostly introducing the internals of Nitro and Nuxt 3. If you have any more questions, I might be available after this chat. And I'm also available on Twitter if you want to just ping me for any question or anything else you have. I would be happy to have a chat. And thank you so much for your attention.